Welcome to PRISM Rounds, the audio journal club where we break down one study at a time for ICU, ED, and pulmonary/critical care teams, physicians, trainees, nurses, pharmacists, and respiratory therapists. A quick note before we start, this episode is created using AI-generated voices. I originally made these episodes to support my own learning and review, and I'm sharing them publicly in case they're helpful to other busy clinicians and learners. Because the voices are synthetic, you may occasionally hear mispronunciations of medical terms, drug names, or author names. Thanks in advance for your patience. Everything you'll hear is for education only and not medical advice. Let's get into today's paper.
Welcome back to PRISM Rounds, and welcome to this deep dive. It is currently, well, I don't actually know what time it is exactly. My watch says 3 a.m., but my body feels like it's floating in a void somewhere entirely outside of space and time.
It is officially ICU time.
It really is.
Mm-hmm.
The unit is finally quiet. Though, I mean, you and I both know quiet is a highly relative term down here.
Yeah, quiet in the ICU just means the chaos has lowered its volume from a dull roar to more of a vibrating hum.
Exactly. The day-rounding teams are long gone, the hospital administrators are asleep in their incredibly comfortable beds, and it's really just us, the night nurses, and the sheer physiology keeping these patients going. And, of course, that one distant ventilator alarm.
Oh, I hear it.
You hear it, right? It's down the hall. I'm thinking maybe bed 12.
Sounds like bed 12.
It's not a high-priority alarm. It's not the one that makes you run. It's just that rhythmic, nagging beep that, honestly, I am pretty sure is just a ghost in the machine at this point.
It really is the soundtrack of the witching hour. And the funny thing is, if it stops, you actually get significantly more anxious.
It is completely Pavlovian. If total silence falls over this unit, my immediate assumption is that a patient has somehow disconnected their own tubing and is currently repainting the ceiling with arterial blood.
That is usually the safest assumption on the night shift, yes.
But look, we're here, we are awake, we have coffee. Actually, can we talk about the coffee for just a second?
Let me guess. Is it the standard night shift break room blend?
It is the standard blend. And I have a working theory about this. Why is night shift coffee always this specific, exact temperature?
I'm not sure what you mean.
I mean, it's not hot. It's definitely not cold. It is this aggressive, lukewarm sludge. It completely defies the laws of thermodynamics. I brewed this pot 20 minutes ago. It should be hot. But it's sitting at exactly 98.6 degrees, like it's, I don't know, mocking me with physiological homeostasis.
I believe the term for that is entropic equilibrium. The coffee is simply matching the ambient energy of the break room. It's effectively a flat line in a paper cup.
A flat line in a cup. That matches my soul right now. It really does. And then there's the pager. You know the rule, right? The gluteus maximus law of paging.
Oh, I'm very familiar with that phenomenon, yes.
Right. So I have been standing at the nursing station for 20 straight minutes. I'm charting. I'm reviewing labs. I am completely unbothered and available. The pager is totally silent. It's a literal brick on my hip. But the exact millisecond, the absolute nanosecond my gluteus maximus touches a chair, it goes off.
It creates a closed circuit. It's basic physics.
It has to be. It's like the pager is hypersensitive to microscopic changes in my posture. It knows when I'm trying to rest. It feeds on my fatigue.
It is a fundamental law of the universe. But, despite the exhaustion and despite the lukewarm sludge currently in your cup, we are actually here to do some evidence-based medicine.
We are. Mostly because we happen to be awake, and the lactate recheck on bed 4 isn't due for another 45 minutes, so we have a small window. So, standard disclaimer for everyone listening before we jump in. We are going to be talking about some really heavy critical care data today. This deep dive is for education. This is for the love of the game. This is not medical advice for you or your patients. Also, if we mispronounce a bug name tonight, just pretend it's a brand new organism that evolved while you were on shift.
Which, given the rate of bacterial mutation in this particular unit, is an entirely possible scenario.
A very distinct possibility. So, what exactly is on the docket for this deep dive?
We are looking at a major paper that dropped in the New England Journal of Medicine on October 29th, 2025. This is the SuDDICU trial.
SuDDICU, pronounced SuDDICU.
Correct. The full title is Selective Decontamination of the Digestive Tract During Ventilation in the ICU.
Okay, let's unpack this immediately. SDD, Selective Decontamination of the Digestive Tract. We really need to set the stage here for you guys listening, because this is not just another random ICU paper. This is, without a doubt, the single topic most likely to start a literal fist fight in an empty workroom. You bring this up at a critical care conference, and people will start throwing chairs.
It is incredibly polarizing,
Right.
and honestly, for very good reason. This debate has been raging since the 1980s.
Which is older than some of our current residents.
It is, and the tension exists because on one hand, you have a massive body of historical literature. We are talking about over 75 randomized trials and multiple large-scale meta-analyses. And historically, the data has been surprisingly consistent. It strongly suggests a mortality benefit.
Which is huge. We need to pause on that word for a second. Mortality. In critical care, we scratch and claw for a 1% benefit. We get wildly excited about a drug that just doesn't kill people faster than the disease does. If you have a protocol that actually lowers mortality, that genuinely saves lives, you usually see it implemented everywhere immediately.
Exactly. The Dutch trials specifically have been very positive on this. They have been doing STD in the Netherlands for decades now. They look at the rest of the world and essentially say, why aren't you saving these lives? We have the data.
But the rest of the world isn't doing it. Adoption is incredibly low in North America, in the UK, in Australia. So why? What is the core fear here?
The fear is essentially the end of days. The conflict boils down to this. Clinicians want the patient directly in front of them to survive. That is the patient-level benefit. You say, I want to prevent ventilator-associated pneumonia in Mrs. Jones in bed 6.
Right. My job is to keep Mrs. Jones alive today.
But the antimicrobial stewardship teams, the infectious disease specialists, and frankly, anyone thinking about the state of medicine 10 years from now, they are absolutely terrified of manufacturing the next superbug.
Right. It's the tragedy of the commons played out in real-time bacterial resistance. I saved Mrs. Jones today, but by flooding the entire unit with heavy-duty antibiotics to do it, I might be dooming the unit to a pan-resistant Klebsiella apocalypse next month.
That is the fear. We're worried we're basically breeding monsters in the drain pipes.
Precisely. It is a population-level risk versus an individual-level benefit. And that is exactly why SuDDICU is such an important, monumental trial. It attempts to answer both sides of that coin in one massive study. It is looking at mortality, yes, but it's also looking very closely at the ecology of the unit itself. Okay, so let's get into the actual intervention itself, section 1 of the outline. What are we actually doing to these patients? Because when I hear the word decontamination, my brain immediately goes to a hazmat shower, or, maybe that scene in a sci-fi movie where you walk through an airlock and they spray you down with white foam. But this is just oral care, right?
It is much, much more than just aggressive toothbrushing. It is effectively the pharmacy moving into the patient's oropharynx. We call it the triple threat.
The triple threat. Okay, lay it out for me. What is in the cocktail? Because I feel like the specific ingredients really matter here.
They absolutely matter. The protocol used in the SuDDICU trial, which, by the way, used mass-produced commercial-grade preparations to ensure complete consistency across all the different hospitals, consists of 3 distinct parts. First, you have a topical oral paste. This paste contains colistin, tobramycin, and nystatin.
Oh, stop. Wait. Colistin.
Yeah.
Colistin. We are leading with colistin. That is the absolute nuclear option.
Right.
For any listeners who aren't currently knee-deep in their hospital's antibiograms, colistin is usually the drug we keep locked behind a thick glass case in the pharmacy that says break in case of apocalypse. It's a polymyxin. It is incredibly nephrotoxic when you give it IV. It basically shreds kidneys. And we are just painting it on their tongues.
That is the beauty of it, theoretically speaking. Colistin targets gram-negative bacteria, the really nasty ones like Pseudomonas and Acinetobacter, by completely disrupting their cell membranes. But, and this is the key pharmacokinetic point, it is very poorly absorbed through mucous membranes or the intact gut.
Oh.
So you can apply a very high concentration topically to kill the bugs sitting in the mouth and the throat, but it doesn't cross over into the bloodstream to kill the kidneys.
Okay, so it's essentially a surface-level nuke. It blasts the local area but doesn't cause systemic fallout.
Exactly. And it is paired with tobramycin, which is an aminoglycoside, that covers a very broad range of gram-negatives as well, hitting any potential gaps the colistin might miss. And then you have the nystatin.
Which is an antifungal.
Right. Because if you wipe out all the bacteria in the mouth with 2 heavy-hitting antibiotics, you create an ecological vacuum. And nature really abhors a vacuum, especially fungal nature. If you don't include the nystatin, you are just setting up a massive Candida festival in the patient's mouth.
A Candida festival is a terrible name for a music festival, by the way.
I certainly wouldn't buy tickets. So this topical paste is applied every 6 hours to the oropharynx and the inside of the cheeks. The goal is to completely coat the area.
Okay, so we are finger painting the mouth with polymyxins.
Yeah.
What is part 2 of the threat?
Part 2 is a gastric suspension. It is a liquid slurry containing the exact same mix, colistin, tobramycin, and nystatin. This is administered every 6 hours via a gastric or a post-pyloric feeding tube.
So we are topically treating the mouth, and we also topically treating the stomach. We're essentially trying to turn the entire upper GI tract into a sterile surgical field.
Correct. The underlying physiological concept here is colonization resistance. The gut is the primary reservoir for these pathogens. Before a bacteria causes a ventilator-associated pneumonia, it usually grows in the stomach, migrates up the esophagus, colonizes the oropharynx, and then gets microaspirated down the ET tube into the lungs.
Okay.
The idea here is to completely suppress that reservoir. You kill the weeds at the root in the stomach before they can ever spread to the lungs.
That logically tracks. But there is a third component to this triple threat, and this is the one that usually makes people really nervous. Frankly, this is the one that makes me extremely twitchy when I read these protocols.
You're talking about the systemic component.
I am. Talk to me about the IV meds.
Right. So patients in the STD group also received a 4-day course of a systemic IV antibiotic. This was typically a third-generation cephalosporin like ceftriaxone or a fluoroquinolone like ciprofloxacin.
And this is given right at enrollment.
Yes, essentially right when they start the trial protocol and get intubated, unless the patient was already on similar gram-negative coverage for a known clinical infection.
See, that is the kicker right there. We spend our entire lives in the ICU trying to stop unnecessary IV antibiotics.
Wow.
I swear I spend half of my morning rounds canceling just-in-case antibiotics that were started in the ER. And here, the protocol literally says, welcome to the ICU. Here is 4 days of IV ceftriaxone, just in case.
It feels incredibly counter-stewardship, doesn't it?
It feels completely reckless. We are handing out third-generation cephalosporins like party favors at the door.
Well, the argument from the STD proponents is hit hard and early. The systemic course is specifically designed to wipe out any early incubation of a respiratory infection that might already be present the moment they hit the door and get intubated. It acts as a bridge.
A bridge to what?
A bridge to the topical therapy. You cover them systemically for 4 days, while the topical paste and the gastric slurry have time to actually decontaminate the gut, because that topical process isn't instant. Once the gut is clean after a few days, you stop the IV antibiotics entirely.
So it's a localized antimicrobial grenade combined with a short, preemptive systemic blitz.
Exactly. And this continues, the topical part, not the IV part, for the entire duration of mechanical ventilation or until day 90 of the ICU stay.
It is aggressive. It is definitely an aggressive protocol. Now let's talk about how they actually studied this, because, correct me if I'm wrong, you can't just run a normal trial here. You can't randomize patient A in bed 1 to get the paste and patient B in bed 2 to get standard care, right?
You have hit on the exact fundamental problem with studying any kind of infection control measure in the ICU. Why do you think that is?
Well, thinking about my own unit right now, the curtains between the beds are flimsy fabric. The nurses constantly cross between rooms. The ultrasound machine goes from bed 4 directly to bed 5. If I am meticulously scrubbing the microbiome of patient A, but patient B is right next door, coughing up a lungful of multi-drug resistant bacteria just 3 feet away.
Exactly. Cross-contamination. The Dutch researchers call this the glitter analogy.
I absolutely love this analogy. Please explain the glitter for the listeners.
Think of the ICU microbiome, the invisible bacteria that live on the bed rails, the privacy curtains, the floor, the physician's stethoscope. Think of all of that as glitter. Have you ever tried to clean up glitter after a kid's craft project?
It is physically impossible. I am pretty sure I still have glitter on me from a birthday party I went to 3 years ago. It is permanently embedded in the grout of my bathroom tiles.
Exactly. Bacteria in a hospital unit behave the exact same way. Once a highly resistant organism is introduced into the unit, it is effectively everywhere. It's on the keyboard at the charting station. It's on the door handles. If I am successfully decontaminating patient A, but patient B is shedding invisible glitter everywhere, patient A is inevitably going to get recontaminated. You simply cannot effectively have-do decontamination in a shared physical space.
So if you ran a standard patient-by-patient randomized control trial,
the standard care control group would be constantly contaminated by the intervention group and vice versa. The overall herd immunity of the unit changes. You would completely muddy the waters of the data and likely vastly underestimate any true effect of the drug.
So how did the SuDDICU investigators get around the glitter problem?
Okay.
Because they had to test this somehow.
They used a cluster randomized crossover design, and I cannot overstate this. This was a massive, monumental undertaking. We're talking about 20,000 total patients involved across 26 different ICUs in Australia and Canada.
20,000. That is a staggering number for a critical care trial. Usually we see an N of like 500, and we get excited that it's adequately powered.
It is massive. But here's the statistical trick. They didn't randomize the individual patients. They randomized the actual ICUs.
Okay, walk me through what that looks like on the ground.
So an entire ICU, let's say Royal Melbourne Hospital ICU, would be randomly assigned to do SDD for a full 12-month period. Every single eligible, mechanically ventilated patient in that entire unit got the paste and the slurry. There was no choice, no bedside randomization. It just became the mandatory unit standard of care.
So the entire physical unit becomes a theoretical clean zone.
Theoretically, yes.
Yeah.
Then after that 12 months was up, the unit would take a mandatory 3-month washout gap.
Like a palate cleanser for the unit. Let the local bugs reset to baseline.
Precisely. You let the glitter settle, and then they would cross over. That exact same ICU would switch to standard care, no paste, no slurry for another full year. Or they would do it in the reverse order depending on the randomization.
So the physical unit itself is the test subject, not just the patient.
Correct. This allows them to treat the whole unit as a closed ecosystem. By treating everyone simultaneously, they minimize the glitter coming from the neighbor's bed. Through this design, they ended up with a randomized cohort, which was about 9,289 patients who were actually ventilated and enrolled in the intervention. And then they had an ecological assessment cohort, which was another 10,711 patients.
We will definitely get to the ecology part in a minute because that is where the real drama lives. But let's look at the primary outcome first. Section 3. This is the reason we do anything in the ICU. Did it actually save lives?
This is the big number everyone was waiting for. The primary outcome was 90-day in-hospital mortality.
Okay, drum roll please. Did the triple threat win?
In the SDD group, mortality was 27.9%. In the standard care group, it was 29.5%.
27.9 versus 29.5. I mean, that looks slightly better. That is a 1.6% absolute difference in mortality.
It is numerically lower, yes. If you just looked at the raw percentages on a slide, you would say, hey, fewer people died when we used the paste. But as always, we have to look at the actual statistics. The odds ratio was 0.94.
Okay.
The 95% confidence interval was 0.84 to 1.05. And the p-value...
Hit me with the p-value. What is it?
0.27.
P equals 0.27.
So statistically speaking, no difference at all.
Correct. It was not a statistically significant reduction in mortality.
So it is not the massive mic drop that the SDD supporters wanted it to be.
No, it is not.
It's more like gently setting the mic down on the podium because your badge reel got stuck on the cord and you don't want to make a scene in front of the audience.
That is a very apt, if slightly depressing, description. I mean, this is incredibly frustrating. We enrolled 20,000 people. 20,000. We spent millions of dollars coordinating this across 2 continents. We literally painted thousands of tons of colistin. And the final answer is just, meh, p equals 0.27.
I completely share the clinical frustration, but we really have to look at the nuance here. The host reaction, the bedside reaction might be, oh, it didn't work, throw the protocol in the bin. But the analyst view, looking at the math, is a bit more complex.
Go on then. Be the analyst. Tell me why I shouldn't just toss this paper in the shredder right now.
Look at that confidence interval again, 0.84 to 1.05. That interval tells us where the true effect of the drug likely lies in reality. The lower end of that interval is 0.84. That represents a 16% reduction in the odds of death. That is huge. If a drug actually does that, that is a blockbuster paradigm-shifting intervention.
Okay, fair.
But the upper end of the interval is 1.05. That represents a 5% increase in the odds of death.
So what you are telling me is it could save a massive amount of lives, or it could actively kill a few extra people.
Exactly. The data is entirely compatible with a clinically important benefit, but it does not absolutely prove it. It effectively leaves the door slightly ajar for the debate to continue.
Which is the worst possible outcome for a clinician standing at the bedside. We desperately want binary answers. We want a guideline that says, do this or don't do this.
Yeah.
I cannot write an order at 3 a.m. for statistically uncertain potential benefit.
Unfortunately, critical care medicine rarely gives us clean binaries. It effectively means the decades-old debate just continues. We can't definitively claim it saves lives based on this specific trial, but we also can't confidently say it's useless. It's a completely agnostic result.
Fine. What about the other stuff? The secondary clinical outcomes. Ventilator-free days. Did they get off the vent faster? Did they leave the ICU sooner? Surely, if we are successfully preventing ventilator-associated pneumonia, they get extubated faster, right?
You would certainly think so, logically. They looked at all of those secondary clinical outcomes: ventilator-free days, high ICU length of stay, total hospital length of stay.
But did we win anything there?
No significant wins there either, I'm afraid.
So it's not even a case of, well, mortality is neutral, but everyone gets to leave the unit by day 3.
No. It's just medicine. The grind just continues. These patients were critically ill, they stayed critically ill, and scrubbing their GI tract didn't magically fix the underlying physiological reason they were intubated in the first place.
Okay, I want to take a brief detour into the math here, because I know for a fact you actually read the supplemental appendix. You're literally the only person I know who enjoys reading supplemental appendices.
I consider it the director's cut of the study. It is where all the real secrets are hidden.
Well, welcome to Section 4, the Stats Corner. You mentioned earlier that this was a cluster randomized trial, and you said that makes the underlying math much harder. Why is that?
Well, in a normal randomized trial, every single patient is an independent data point. Patient A has nothing to do with patient B. But in a cluster trial, patients in the same ICU are inherently related to each other. They share the same doctors, they share the exact same nursing protocols, the same air, the same glitter.
Right. If the unit is good, everyone does well.
Exactly. So you can't treat them as completely independent. If ICUA is just intrinsically really good at weaning ventilators and doing spontaneous awakening trials, all their patients will look better on paper, regardless of whether they got SDD or not. You have to mathematically correct for that clustering effect. We call it the intraclass correlation coefficient, or ICC.
ICC. Sounds like a federal government agency coming to audit my charting.
It basically measures how much clumping or similarity there is in the data within one specific hospital. Because of this clumping, your effective N isn't really 20,000 independent patients. The N that matters most for the statistics is actually 26 the number of ICUs.
And 26 is a very small number when you're trying to power a mortality difference.
It is. That drastically reduces the statistical power of the study to find a small difference. To handle this mathematically, they used a very specific analysis, an individual patient-level hierarchical logistic regression model.
Now you're just making up words to sound smart at 3 a.m.
I promise I'm not. It accounts for the random cluster effect and the random cluster period effect, but here is the absolute gem that I know you will appreciate. To calculate the degrees of freedom, basically, how much mathematical wiggle room the stats have, they used a very specific correction formula.
Which was what?
The Kenward-Roger correction.
So stop right there. Kenward-Roger.
Yes. It is a standard statistical correction for small sample sizes and mixed models.
No, it is not. Kenward-Roger sounds exactly like a personal injury law firm that advertises on daytime television. Have you been injured by a random cluster effect? Call Kenward-Roger now.
We specialize in ICU malpractice and cluster period correlation. We will get you the compensation you deserve.
I was just minding my own business in bed 6, and then out of nowhere, the cluster effect hit me. I lost 3 degrees of freedom, and I can't work anymore.
Call 1-800-KEN-RAJI. We fight for your p-value.
I can literally see the billboard on the highway next to the hospital, a guy in a suit, pointing sternly at a Kaplan-Meier curve.
Jokes aside, though, using the Kenward-Roger correction is actually a massive sign of quality for this paper. It shows the statisticians were being incredibly rigorous. They didn't want to cheat the math and pretend they had more power than they actually did. They were being very conservative.
Fair enough. We respect honest, conservative stats on this show, even if they sound like ambulance chasers. Okay, let's move to Section 5, the microbiology drama. Because this is where the story gets really complicated. This is where that superbug fear we talked about comes into play.
This is absolutely the crux of the entire SDD debate. We have 2 parts to look at here: the good news and then the cautionary tale.
Start with the good news. I need the good news right now. This is looking at the randomized cohort, right? The actual patients who got the paste and the slurry.
Right. When the investigators looked at the ventilated patients specifically enrolled in the trial, they found that new bloodstream infections bacteremia were reduced in the SDD group. It was 4.9% versus 6.8% in standard care.
Okay, that's a very decent drop. Less bacteremia in the ICU is generally a very good thing.
It is. And here's the really surprising part for some people. The rate of antibiotic-resistant organisms showing up in cultures was significantly lower in the SDD group, 16.8% versus 26.8%.
Wait, pause. Let me make sure I have this totally straight. We are pouring broad-spectrum antibiotics into the patient's stomach. We are literally painting their mouth with tobramycin. We are pumping colistin into their GI tract every 6 hours. And resistance actually went down.
And the individual patient who received the drug, yes, resistance went down.
That feels completely counterintuitive to everything I have ever been taught about stewardship. Usually, more antibiotics equals more resistance. Every single time.
It makes complete sense if you think about the physiological mechanism we discussed earlier. Think of it as weeding the garden. By heavily suppressing the gut reservoir, you physically prevent the overgrowth of these highly resistant gram-negatives in that specific patient. You are essentially clearing the entire field. The patient doesn't develop a resistant VAP or a resistant bloodstream infection because you never gave those resistant bugs a chance to bloom in the gut in the first place.
Okay, so for the actual patient lying in the bed, it looks really good. Fewer bugs in the blood, fewer resistant cultures on their chart. I am successfully weeding their personal garden. But you mentioned a cautionary tale, and I feel a massive but coming.
This is part B of the drama, the ecological assessment.
The glitter check.
Exactly, the glitter check. They didn't just test the ventilated patients getting the drug. They tested everyone in the entire unit, even the awake patients, not on vents, who weren't getting the SDD protocol at all. They did these massive monthly point prevalence surveys, swabbing rectums, swabbing throats of every single patient present on that day.
A truly glamorous job for the clinical research coordinators.
Science is rarely glamorous at the ground level. They wanted to know a very specific thing. Is the ambient glitter in the unit becoming more resistant overall? Are we, by using all this colistin and ceftriaxone, accidentally selecting for a super bug that is going to permanently colonize the privacy curtains and the sink drains?
Are we breeding the monster in the background while we are distracted saving the patient in front of us?
Exactly. So they tested this mathematically for non-inferiority using a margin of 2 percentage points.
Yeah.
They were basically asking the stats, can we definitively prove that we are not making the unit worse?
And the result of that non-inferiority test?
Non-inferiority was not confirmed.
Oof. That is the sound of a very large balloon deflating.
Now, be careful with the interpretation here. That does not mean it was confirmed to be worse. It simply means they couldn't statistically prove that it wasn't worse.
That sounds incredibly like lawyer speak again. Kenward Roger would be extremely proud of that phrasing. Translate that for the clinician at the bedside.
The confidence intervals around the ecology data were very wide. The actual data could support anywhere from a 7.4% reduction in unit-wide resistance, which would be amazing, all the way to a 4.8% increase in unit-wide resistance.
So it's essentially a giant shrug emoji, but a very scary shrug emoji.
It is a statistical, we really don't know for sure. And in the world of infectious disease and hospital stewardship, we don't know if we are creating superbugs, is a highly uncomfortable place to be.
I mean, this is the absolute nightmare scenario for an ID doctor, isn't it? The study was only 12 months long per intervention period. Biology plays the long game. Evolution takes real time. If we did this protocol consecutively for 5 years, would that potential 4.8% increase slowly snowball into a 20% increase?
That is the great unanswered question of SuDDICU. The cautionary tale here is that while the patient right in front of you might have fewer resistant bugs during their stay, the long-term multi-year impact on the unit's overall ecology remains statistically uncertain. We might genuinely be selecting for something very nasty over a longer timeline than the trial actually measured.
So the implication for practice is, we simply cannot promise safety at the unit level. I can help the guy in bed 4 today, but I might be actively making life significantly harder for the guy who occupies bed 4 next year.
That is the pure essence of the ethical dilemma of SDD. It directly pits the immediate survival of the individual against the future safety of the collective.
Wow. Okay, let's pivot and talk about safety in the immediate physical sense, because giving all these drugs has to have side effects. Did the paste cause physical problems? Did people have severe allergic reactions? Did their tongues turn blue and fall off?
Surprisingly, adverse events were very rare. Documented adverse drug reactions were 0.3% in the SDD group versus 0% in the standard care group.
0.3%, so basically zero.
It is negligible. And really importantly, there was no significant difference in the rates of Clostridioids difficile infections.
C. diff. That is always my first fear when I hear 4 days of IV ceftriaxone. You give heavy broad-spectrum antibiotics, you completely wipe out the good protective gut flora, and C. diff just takes over the neighborhood.
Exactly. That is the classic pathway. But it simply didn't happen here. The rates were essentially identical between the two groups. It seems that the triple threat protocol physically suppresses C. diff spores as well, or at the very least, it doesn't promote their overgrowth.
So there were no STD-related catastrophes, no
Yeah.
doom-paste scenarios.
No doom paste. It appears to be extremely safe for the individual patient receiving it.
Okay, what about subgroups? Because whenever we have a massive trial with 20,000 people that shows a neutral primary outcome, there is almost always one tiny subgroup where the signal looks stronger. Is there anyone this actually works for?
Yeah.
Trauma patients, the big surgical patients.
They looked at a lot of factors: age, severity of illness scores, surgical versus medical admission. Nothing really jumped out across the board. The interaction p-values were simply not significant. However,
There's always a however in these papers.
there was a post-hoc analysis regarding patients admitted with an acute brain injury.
Acute brain injury, so we're talking TBIs, massive strokes, subarachnoid bleeds.
Exactly. There was a statistical signal suggesting a potential mortality benefit, specifically in that neurocritical care group.
Okay, but you said the magic words just now. You said post hoc.
I did say post-hoc.
Post-dismissal mode fully activated. Post hoc is just the Texas sharpshooter fallacy in lab coat. You know the one, right?
Please enlighten the listeners.
It's a classic stats joke. You shoot a bunch of random bullet holes into the side of a barn. Then you walk up to the barn, draw a bullseye directly around the tightest cluster of holes you accidentally made, and you proudly claim to everyone that you're a master sniper. That is post hoc analysis. You run the trial, you fail to find a difference in the main group, so you slice the data 50 different ways after the fact until you find the one random group that did well, and you say, aha, look here.
That is a very fair, if cynical, critique. A post hoc finding generates a hypothesis for future testing. It absolutely does not prove it.
But just playing devil's advocate, why would it hypothetically work better in a brain injury patient, physiologically speaking?
Well, patients with severe acute brain injury often have deeply impaired gag reflexes. They cannot protect their own airway. They microaspirate constantly, even with an ET tube cuff fully inflated. So maybe, just maybe, systematically sterilizing the exact secretions they are constantly aspirating is much more high yield in that specific population compared to a standard medical patient.
I mean, that logically makes sense. Ventilator-associated pneumonia is very often what actually kills the severe TBI patient who manages to survive the initial traumatic hit to the head.
Exactly. The secondary injury from sepsis is lethal, but again, you cannot firmly hang your hat on it based on this trial alone. It's an interesting signal. It's like looking at a weird rhythm strip on the monitor.
Yeah.
You document it, you say, huh, look at that, but you don't instantly build an entire hospital protocol around it yet.
All right, so we were nearing the end of our shift, or the end of the deep dive at least. I can see the sun starting to come up through the tiny sliver of window at the end of the hall. The night shift vampires are retreating. We have to do the Monday morning reality check.
The final synthesis.
I am the medical director of this ICU. It is Monday morning. I have a freshly printed copy of this NEJM paper sitting on my desk. Do we change practice today? Do I start ordering industrial buckets of colistin paste? Do I call the pharmacy and tell them to start mixing up the sludge for every intubated patient?
The final verdict from the data is, it is not a slam dunk.
Break that down for me. Give me the executive summary for the director.
You cannot definitively claim a mortality benefit. The primary outcome p-value is 0.27. If you go to your hospital administration and boldly say, this paste saves lives, you are simply not supported by the rigorous data. The finance guys will laugh you right out of the budget meeting when they see the cost of the drugs versus the p-value.
And rightly so, honestly.
On the flip side, you do have highly favorable culture data for the individual patient. Less bacteremia is unequivocally a good thing. If you run a unit that is absolutely plagued by VAP and gram-negative bloodstream infections, maybe that specific finding matters a lot to your local practice.
Yeah.
But you have this massive unresolved safety signal regarding the unit's long-term ecology. You cannot mathematically prove you aren't hurting the unit's resistance patterns long-term.
So if a unit actively wants to do this, let's say there's an ICU director out there who really believes in the historical Dutch data, looks at SuDDICU, and says, I'm willing to risk the ecology for the individual benefit.
If a unit wants to implement this, they absolutely cannot just turn the protocol on and walk away. They can't just buy the paste and assume everything is fine. The defining phrase needs to be, show me your stewardship plan.
Don't just do it. intensely monitor it.
Exactly. You need to be actively swabbing patients. You need to be meticulously tracking your unit's resistance patterns on a monthly basis. You need a live dashboard. If you start seeing carbapenem resistance creeping up at month 6, you need a pre-planned hard kill switch to stop the protocol immediately.
And local context completely matters here.
Right.
Where was this study predominantly done again?
Australia and Canada?
2 countries with generally very low baseline rates of multi-drug resistance compared to the rest of the world.
Correct. If you try to blindly transplant this exact SuDDICU protocol to an ICU in Southern Europe or in India or even certain parts of New York City where CRE carbapenem-resistant Enterobacteriaceae is already highly endemic, the results may be disastrously different.
Right. If the glitter in your unit is already diamond-hard, pan-resistant super glitter, the colistin paste might not do a single thing. Or worse, it might selectively kill the weak bugs and let the super glitter completely take over the unit.
Exactly. The baseline ecology of your specific hospital dictates everything. So, no, we do not radically change practice on Monday everywhere. It is not a sweeping mandate.
It's not a mandate. It's the start of a very complicated conversation with your ID doctors and your pharmacists.
As most good, nuanced medicine is, it's fundamentally about weighing the immediate risk to the patient against the theoretical risk to the broader population.
And getting deeply comfortable with a high level of ambiguity, which, coincidentally, is the exact definition of working a night shift in the ICU.
Comfort with chaos. That should be on our badges.
All right, let's wrap this up. Let's do a quick recap for the people who are currently driving home or the nurses out there charting their 4 a.m. vitals and trying to stay awake.
SuDDICU trial. New England Journal of Medicine, October 25. 20,000 patients. Cluster randomized crossover design. Tested STD, the topical oral paste, the gastric slurry, and the short YV course.
The triple threat.
Result, no statistically significant mortality win. 27.9% versus 29.5%, with a p-value of 0.27. It showed reduced infections and resistant cultures for the individual patient, but left us with lingering ecological uncertainty for the overall unit.
And it gave us a really cool glitter analogy that I am definitely stealing for teaching rounds tomorrow morning.
And of course, a very special shout out to the prestigious personal injury law firm of Kenward Roger.
Long may they practice cluster period correlation law. All right. The unit is really starting to wake up now. I can hear the phlebotomy blood draw cart rattling down the hall. That specific squeaky wheel sound always fills me with a very specific, deep kind of dread.
It means the day team is coming soon. The sun is rising.
It means we actually have to stand up, calculate our ins and outs, and present these patients. Time to get back to the real work.
Indeed it is.
To all our listeners out there in the dark, hydrate, eat a protein bar, and I mean a good one, not the chalky kind. Treat yourself to the chocolate peanut butter one, and please remember that p-values don't titrate pressors.
Stay safe out there. Think about what the baseline resistance in your own unit actually is right now before you even consider this.
No, go silence that alarm respectfully.
Thank you for spending your time with PRISM Rounds. If this episode helped you think through the paper or offered something practical for the bedside, I'd be grateful if you'd like, follow/subscribe, and share it with a colleague. It's the simplest way to help this resource reach other busy clinicians and learners. I'm also trying to make the podcast better with every episode. Please leave a comment with what you found most useful, what felt unclear or too long, and what topics or papers you'd like covered next. If there's anything I can do to improve, pacing, structure, level of detail, or audio quality, I genuinely welcome the feedback. Thanks again for listening, and take care. Educational use only. This is not medical advice.